In the world of AI, there is one question that changes everything. How do we actually know if these things are smart, safe, and, well, reliable? We're going to take a look inside LLM evaluation and benchmarking. I mean, think about it. We all use these tools now, right? We're asking them for facts, for summaries, for advice. But how do we really know if the answers we're getting are legit? How can we actually trust them? It's such a simple question, but the answer is surprisingly deep. And this quote, it just hits the nail on the head. Without a formal, really rigorous way to test them, these incredibly powerful AI models are basically a black box. It's all just untested guesswork. We're just crossing our fingers and hoping for the best. And that's exactly why the entire industry is shifting its thinking. We're moving away from just, observing what an AI can do and moving towards systematically measuring it. It's the difference between a cool party trick and a professional tool you can actually rely on. And believe me, these tests aren't just for academics. They are super practical. We use them for everything, from the big picture stuff like comparing giants like GPT-4 versus Claude, all the way down to the nitty-gritty, like making sure a tiny update didn't accidentally break the whole system. And maybe most importantly, these tests tell us if an AI truly gets a specialized field, like finance or law. So, how do we actually do all this measuring? Well, it all boils down to one foundational tool, the evaluation dataset. Let's pull back the curtain and see what that really is. Okay, the easiest way to think about it is like a final exam for the AI. Seriously, it's the super carefully crafted set of questions. Those are the inputs, and each one has a perfect pre-written answer. We call that the gold standard output. So we just compare the AI's answer to our gold standard, and boom, we can give it a score. Now, these exams come in three main flavors. You've got your synthetic data sets, which are actually generated by another AI, awesome for making tons of test questions really fast. Then there's real user data, which gives you the most realistic scenarios because it's pulled from actual human conversations. And finally, you have domain-specific sets, which are laser-focused on testing really specialized knowledge. But here's the secret, you don't just pick one. The absolute best practice, the real gold standard, if you will, is to use a mix of all three. That combination is what gives you the most complete, the most robust picture of what an AI can really do. Let's zoom in even closer. Every single question in one of these datasets is just packed with information. It's not just the prompt and the perfect answer, it's got all this other metadata, like what topic it is, how hard it is, and even reference documents for some of the more advanced tests. And if you were to look under the hood, a single test item often looks just like this little code snippet. You've got your key fields, the prompt, that's the question we ask the AI, and the gold_answer. That's the perfect response we're grading it against. Okay, this all sounds pretty amazing, but it kind of begs the question, right? Where do these thousands of perfectly crafted test questions actually come from? Let's get into how they're built. So, like we said, there are two main paths you can take. You can collect real-world data from stuff like customer support chats or company FAQs. This stuff is incredibly realistic, but man, it takes a ton of work to clean it up and make it anonymous. The other path is synthetic data, where you just use another AI to generate your test questions. It's way faster for sure, but it might not capture all the weird, messy ways that we humans actually ask questions. And when I say preparing real-world data is a lot of work, I mean it. It's this whole rigorous process. First, you have to strip out any personal info, then clean up all the duplicates, categorize everything, and then, this is the most important part. You have experts come in and assign those gold standard answers before a final human quality check. This right here is where testing becomes a real competitive advantage. A generic test just can't tell you if an AI understands complex tax law or can interpret a medical chart. Building these deep, domain-specific datasets, it's not just a nice-to-have. It's absolutely essential if you want to create AI that's actually useful and safe in a professional setting. But look, it's not enough to just test for standard knowledge. To really understand what an AI is capable of, you have to push it to its absolute limits. And for that, we have what are called stress tests. Think of this as an AI obstacle course. We throw everything at it. I'm talking 10,000-word documents, questions that are full of typos and slang, even attempts to trick it with something called prompt injection, where you try to make the AI ignore its own rules. These tests are designed to find the breaking points and see how tough the AI really is. And there's another special case. A lot of modern AIs use this technique called retrieval augmented generation, or RAG for short. It's basically where they look up info in documents you give them before they answer. And testing these systems, that requires a whole unique approach. When you're grading a RAG system, it's all about faithfulness. Did it actually use the documents we gave it? Did it just make stuff up that wasn't there? That's what people mean when they say hallucination. And maybe just as bad, did it leave out any crucial facts that were right there in the text? Now here's the thing. All of this testing, it's not a one-time event. The most sophisticated teams out there, they treat this as a continuous process. It's like a never-ending report card for their AI. So what's on this report card? Well, it tracks all the key metrics. You've got accuracy, of course, but it also measures the hallucination rate. It's constantly checking for safety and bias, and it even keeps an eye on practical things like how fast it is and how much it costs to run. It's a complete health check for the model. The ultimate goal is to make this whole thing automatic, to build it right into the development pipeline. It's what the software world calls CI/CD. This means the top teams are running benchmarks automatically, every single day to catch any drop in quality, and with every single update to make sure nothing broke. It's just a constant cycle of test, improve, repeat. Which brings us to this really powerful final idea. Benchmarks. They aren't just tests to see if you pass or fail. They are a strategic tool. They're your compass. Think about what a compass does. It guides you. It tells you where you're going. That's what benchmarks do. They show you where the model is getting weak, where it's strong and you can trust it, and ultimately, how close you are to building an AI that delivers real, actual value. In the end, this whole thing is about moving from guesswork to governance. It's about building AI that we can measure, that we can manage, and most importantly, that we can trust. So the next time you use an AI tool, it's worth asking yourself, how is this thing I'm using being guided?